Okay, I'm going to go through this fairly quickly. So make sure that you are correcting as we go. If you have questions, let me know and I'll stop and address those. The first four problems, you're just calculating the logarithms. And these logarithms are just asking specific questions. Like on number 1, this is asking 5 to what power equals 625. You can do this in your calculator and find that answer is 4. Okay, number 2, this logarithm is asking 2 to what power equals 1/8. If you have a whole number and you're raising it to a power, and you end up with a fraction, that means that your exponent has to be negative. In this case, it's -3. Number 3, 10 to what power equals 1,000? If it's 10 being raised to a power, you can find your answer by looking at how many zeros are in the number you end up with. So 3 zeros in 1,000 means this answer is 3. Number 4, 27 to what power equals 3? If you raise a number to an exponent and you end up with a smaller whole number, not a fraction like in number 2, just a smaller whole number, that means your exponent will be a fraction. It'll be 1/2, 1/3, 1/4, or so. Any one like that has a 1 in the numerator. The answer on number 4 is 1/3. Numbers 5 through 8, it's asking for you to convert between exponential and logarithmic form. You don't have to solve anything, you're just converting back and forth. Number 5, this is in exponential form, which means we need to change it to logarithmic form. So the first thing we need to write is log. Then you can use the loop trick by starting at the base, which is 3, and draw a counterclockwise loop around to the exponent. And that is the order that you'll write these in the logarithm. So you'll start with 3. So log base 3 of s equals t. On number 6, you're starting in log form, and we need to change this to exponential form, which means we don't need the log. We can just start at the base, draw a counterclockwise loop. So this will be a to the c power equals b. Number 7 will be log base h of 12 equals k. And number 8, 5 to the x power equals w. Starting with number 9, we're using the properties of logarithms to solve. You need to make sure and show your work, but you only have to check your answers if you get more than one value for x. That should only happen on number 11. On number 9, we have a logarithm on one side of the equal sign with just a number on the other side. When you have something like this, the first thing you need to do is change to exponential form. So the exact same thing you just did in number 6 and number 8. So this will be 3 squared equals 2x minus 1. Once you've changed to exponential form, then you can just start solving for x. So I want to add 1 to both sides. 3 squared is 9, plus 1 is 10, equals 2x. Divide both sides by 2 to get x by itself. So we get x equals 5. Any questions on the first page? All right. Number 10. On number 10, we have a logarithm that's equal to another logarithm. As long as they have the same base, which in this case they do, they both have a base of 5, we can leave the logarithms off and set x plus 5 equal to 4x minus 1. Okay, so now we can solve for x. If you're moving things around to get x by itself, you may have done steps in a different order than I did. That doesn't make it wrong. So if I do something different than what you have, don't erase it right away. Wait and see what I get for x and check your answer, and then see if you made a mistake somewhere. I would subtract x from both sides, which is going to put my x values over here. So I'm going to go ahead and get rid of this -1 by adding 1 to both sides in the same step. Again, you could have done this differently than me, and that's fine. So I get 6 equals 3x. So now I'll just divide both sides by 3 to get x by itself. So I get x equals 2. Okay, number 11. We have 2 logarithms on the same side of the equal sign. If that happens, you need to combine those into one logarithm before you do anything else. So when we combine logarithms, the base stays the same. So it's still log base 4. And then since these logarithms are being added together, that means we multiply x times x plus 6. So we've got log base 4 of x times x plus 6 equals 2. Now we have a logarithm on one side with just a number on the other side. So this is basically how we started in number 9. And what we did in number 9 was to change to exponential form. So that's what we'll do here. 4 squared equals x times x plus 6. Let's go ahead and multiply by distributing the x. So we get x squared plus 6x. If you have an x squared and just an x term, that should tell you that you're going to have to factor to find your answers. And in order to factor, we need everything on the same side of the equal sign. So we need to get rid of this 4 squared, or we need to move it to the other side. So 4 squared is 16. So let's just subtract 16 from both sides. So we get 0 equals x squared plus 6x minus 16. I'll go ahead and tell you, your semester test will be in the exact same format as this review, even down to the fact that on number 11 on the test, that will be the one you have to factor on. So the numbers within the problem might be different, but the method that you use to solve number 11, you're going to use that same exact method to solve number 11 on the test. So like on number 10 on the test, you're going to have 2 logarithms equal to each other, and you're going to use that same method to solve, even if the numbers are a little bit different. Okay, so number 11 on the test will be the one you have to factor on. Okay, so let's factor into 2 sets of parentheses. And we know that x goes in the front part of both of those parentheses. Then we need two numbers that multiply to be -16 and add to be 6. If you have trouble coming up with those numbers, here's what I do. I take -16, I list out the pairs of numbers that multiply to be -16. So 1 and 16, 2 and 8, 4 and 4. Those are the factors of 16. Now looking at each pair, it should be a little bit easier to see 2 and 8 is what I need to use. And it needs to be +8 and -2, so that when you multiply them, you get -16, and when you add them, you get a +6. Okay, but these are our factors. They're not our answers. If x plus 8 is one of our factors, that means x equals -8 is one of our answers. So same number, flip the sign. So if x minus 2 is one of our factors, x equals +2 is one of our answers. So now, since we have more than one answer, this is the one we have to check our answers on. When you check your answers, you have to go all the way back to the very first line of the problem. You can't just pick a line in the middle here and start with it. You have to start from the beginning. So if we're trying -8, we're just going to take that first line, but instead of x, we're plugging in -8. Before you continue checking, these numbers that are inside of these logarithms, you can't have a negative number there. So the fact that this is a -8, this turns out to be a -2. Because we have negative numbers where we're not supposed to, we can say x equals -8 is not a solution. So we can mark it out. You don't have to go any further checking it. But now we need to check x equals 2. So again, we're starting from the very first line of the problem, but instead of x, we're plugging in 2. So we have a +2. We have what turns out being a +8. So we don't have any negative numbers to worry about. That means we can continue checking. So we're going to do the same first couple steps that we took when we were solving. So we're going to combine these two logarithms into one. So we've got log base 4. And then we're multiplying 2 times 2 plus 6, which is 8. Then we're going to change this to exponential form. So 4 squared equals 2 times 8. And now we just need to make sure that these numbers are in fact equal. 4 squared is 16. 2 times 8 is 16. They are equal. So x equals 2 is a solution. We circle it, box it in, whatever you want to do there. Okay, number 12. On number 12, again, we have more than one logarithm on this side of the equal sign. So the first thing we need to do is combine those into one logarithm. When you combine logarithms, the base stays the same. So it's still log base 4. This time, these logarithms are being subtracted. In number 11, they are being added. So we multiplied. Now they're being subtracted, which means we divide. 91 divided by x. And that is still equal to log base 4 of 13. Okay, now we've got one logarithm on both sides of the equal sign. Because they have the same base, just like in number 10, we can leave them off. And we can just set 91 over x equal to 13. Now to solve for x, we need to get rid of this fraction. To get rid of a fraction, we multiply both sides by the denominator. So we're going to multiply both sides by x. Excuse me. So these x's will cancel out and leave us with 91 on this side. 13 times x is 13x on this side. Now all that's left to do is divide both sides by 13. That gets us x by itself. 91 divided by 13 is 7, so x equals 7. Any questions on this page or numbers 9 through 12? So again, the questions you will use the same method to answer each question that you used on the review. So on number 12, you'll have two logarithms that are being subtracted. You'll need to combine them. Then you'll need to drop the logarithms. Even if the numbers are a little bit different, you're going to be using the same steps to solve. Okay. Number 13. We're solving the system of equations by substitution. So substitution means you're solving for one of the variables and then you're plugging that in for that variable in the other equation. This second equation is already solved for y. So I'm going to use this 2x and substitute it in for this y in the other equation. So 4x plus 2x equals 6. So I just replaced y with what y is equal to, which is 2x. Now I have an equation that only has x variables, so I should be able to solve for x here. Combine like terms, and we get 6x equals 6. Divide both sides by 6 to get x by itself, so we get x equals 1. Now that we know what x is, we can go into this equation that's already solved for y and plug in our value for x. So y equals 2 times 1, which is 2. Okay, our instructions say to write your solution as an ordered pair. So our solution is 1, 2. On number 14, we don't have one of our equations already solved for a variable, so we're going to have to do that extra step. If you look in the second equation, it's going to be real easy to solve for this x by subtracting 2y from both sides. So that gives us x equals 7 minus 2y. So instead of x in this equation, we can substitute in 7 minus 2y. So 4, and instead of x, we've got 7 minus 2y. Then minus 5y equals negative 11. Now we need to solve for y. So let's get rid of these parentheses by distributing the 4. 28 minus 8y minus 5y equals negative 11. Combine like terms. Negative 8y minus 5y is negative 13y. Subtract 28 from both sides. So we're left with negative 13y equals negative 39. So then we need to divide both sides by negative 13. Negative 39 divided by negative 13 is positive 3. So y equals 3. Okay, now that we have y, we can go back to our equation that we already solved for x. Plug in our value for y. So x equals 7 minus 6, which is 1. Our solution for number 14 is 1, 3. On numbers 15 and 16, we're solving by elimination. So you need to choose either the x's or the y's to get rid of, or to try to get them to cancel out. Here, if I look at the x coefficients, we've got 4 and 3. The y coefficients are 3 and 2. Just because the y coefficients are barely smaller, that's the one I always choose to work with, is whichever one's smaller. But it really doesn't matter which one here. If I want the y's to cancel out, I know 3 and 2 will both go into 6. So I want those to both be 6, but I want one of them to be negative. So I'm going to multiply the first equation by negative 2 and the second equation by 3. You could have done this a little bit differently. But it doesn't mean it's wrong if you did it different than what I'm doing it. If I multiply everything in this equation by negative 2, I get negative 8x minus 6y equals negative 2. When I multiply this equation by 3, I'm going to go ahead and write it just below this one. That way they're ready to be added to each other. So 3x times 3 is 9x. 2y times 3 is 6y. And 2 times 3 is 6. So you see we got a negative 6 and a positive 6. That's going to eliminate the y variable. We have negative 8x plus 9x, which is just x. Negative 6 and positive 6 cancel out. And negative 2 plus 6 is a positive 4. So we've already got our x value, it's 4. Once you have one value, you go back to either one of the original equations, plug that value in, and you'll be able to get the other variable. So I'm just going to use the second equation. We've got 3x, so we know x is 4, plus 2y equals 2. So that's 12 plus 2y equals 2. Subtract 12 from both sides. We get 2y equals negative 10. Divide both sides by 2 to get y by itself. So y equals negative 5. Our solution as an ordered pair is 4, 5. Number 16. I immediately notice that the y coefficients are already opposite signs. One's positive and one's negative. So that draws my attention. And then this is a -2. So if I just multiply it by 2, it will give me a -4. That could cancel out with this +4, and we could eliminate the y's again. So in number 15, we had to multiply both equations by something to get a variable to cancel. In this one, all we have to do is multiply this equation by 2. We don't have to multiply this equation by anything. So you're not always going to have to multiply both equations by something. It could just be that you have to multiply one equation by something. Okay, so I'm going to multiply this equation by 2. When I do that, I'm going to go ahead and write it below this one. That way they're ready to be combined. So I get 8x minus 4y equals 4. Combine these, we get 16x. The y's cancel, equals 4. Divide both sides by 16. That gets us x by itself. 4 over 16, you can do that in your calculator and simplify the fraction. You get 1/4. If you put 0.25, I'm okay with that too. Once we have our x value, you can go back to either one of the original equations, plug that in, and we can get our y. I'm just going to use the second equation here. So we got 4x, but we know x is 1/4, minus 2y equals 2. Four times 1/4 is 1. Minus 2y equals 2. Subtract 1 from both sides. So we get -2y equals 1. Divide both sides by -2. That gets y by itself. So y equals -1/2 or -0.5. If you used a decimal, that's fine. Our solution as an ordered pair, 1/4, -1/2. Questions on this page? Solving systems. All right. Do some matrix operations. Number 17, we're just adding two matrices. So we just need to add corresponding elements. 5 plus -4 is 1. -6 plus 6 is 0. 8 plus 8 is 16. And 9 plus -3 is 6. Number 18, we're adding again. 2 plus -6 is -4. 5 plus 3 is 8. And 8 plus 12 is 20. We are subtracting on number 19. So -5 minus -3, that's the same as -5 plus 3, which is -2. 6 minus 2 is 4. 2 minus 5 is -3. 4 minus -8 is the same as 4 plus 8, which is 12. Subtracting on number 20. 8 minus 3 is 5. 6 minus 5 is 1. -4 minus -8 is the same as -4 plus 8, which is 4. Number 21, this matrix is being multiplied by 5. So all we have to do is multiply everything in that matrix by 5. 2 times 5 is 10. Negative 3 times 5 is negative 15. 0 times 5 is 0. And 4 times 5 is 20. So I didn't give you two matrices being multiplied to each other. Also didn't give you any solving systems of 3 equations, the ones that had the x, y, and z. So can't say I never did anything for you. You're welcome. Anytime. Okay, we do have 4 inverse functions problems though. You're going to use the same 4 steps on all of these problems. Change function notation to y, change or switch x and y, solve for y, and then change back to inverse function notation. Okay, so here we're going to change f of x to y. Then we're going to switch the x and the y. From here, the things that you have to do to solve for y is going to be different in each problem, but you still have that ultimate goal of getting y by itself in all of them. So right now we have a fraction. If we want to get rid of a fraction, we multiply both sides by the denominator. So we're going to multiply both sides by 3. So that gets me 3x equals, the 3's cancel on this side and leave us with negative y minus 5. So multiplying both sides by 3 should have been your first step. From this point on, if you do things in a different order than I did, it's probably okay. I'm going to add 5 to both sides. So I get 3x plus 5 equals negative y. And then I need my y to be positive, so I'm going to divide both sides by negative 1. So that gets me y by itself. Y equals 3x plus 5 over negative 1. Now your answer could look different from this, but it should at least have f inverse of x. Then you could leave it as this fraction, 3x plus 5 over negative 1. Or you could go ahead and divide everything by negative 1, and that would make that negative 3x minus 5. So either one of these is fine. Can't think of another way that you could have it. Does anybody have something different and you want to know if it's right? Okay. Either one of these is correct. Okay, number 23. Change g of x to y. And switch the x and the y. Those 2 steps should be automatic. Now from here, when we're trying to get y by itself, again, you might do some things differently than me or from each other. As long as you're doing all the math correctly, you'll be fine. So I'm going to add 1 to both sides. So that gives me x plus 1 equals negative 1/5 y. Now to get y by itself, I'm going to divide both sides by negative 1/5. So that gets me y equals x plus 1 over negative 1/5. So again, there are some different ways that you could write this. You need to have g inverse of x. We started with g of x, so this is g inverse of x. And you could have left it as that fraction, x plus 1 over negative 1/5. Or you could have g inverse of x equals, you could go ahead and divide both of these things by negative 1/5, which would give you negative 5x minus 5. Or you could have the same thing that I have in this one, but all the signs flipped. So negative 1 minus x over positive 1/5. Does anybody have something different than these three that you want to know if it's right? Okay. Number 24. Change function notation to y. Flip the x and the y. And then we want to solve for y. So I'm going to add 1 to both sides. That gives me x plus 1 equals 2y. And I'm going to divide both sides by 2 to get y by itself. So y equals x plus 1 over 2. So your answer, h inverse of x, you could leave it as x plus 1 over 2. You could go ahead and divide everything by 2. So you get 1/2 x plus 1/2. Or you could have negative 1 minus x over negative 2. Oops. Any one of these three is correct. You don't have to have it written all these three ways. I hope you understand. You could have it any one of these three, and it would be correct. Okay, last one. Change function notation to y. And switch the x and the y. Then we want to get y by itself. So we're going to subtract 2 from both sides. So x minus 2 equals y cubed. The way that we get rid of this exponent of 3 is by taking the cube root of both sides. Because the cube root cancels out the exponent of 3, which gets y by itself. So y equals the cube root of x minus 2. Change back to inverse function notation. K inverse of x equals the cube root of x minus 2. I can't think of a different way that you could have it. This will probably be the only answer.